Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll get to as many questions as we can before the end of today's webinar. Also at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is Integrate Security Early and Often for Successful DevSecOps. Our speakers today are Alyssa Miller, who is Application Security Advocate at Snyk, and Garrett Gross, who is Senior Solutions Engineer, Application Security Specialist at Rapid7. Welcome to you both. Thanks for joining me today.
Yeah, hi, Charlene. Thank you so much. And thanks, everybody, for being here today. So as Charlene mentioned, we are going to tackle a topic that tends to still elude a lot of us, especially from a security perspective, and that is the whole idea of how do we introduce security or more effectively bring security into a DevOps culture. So just to introduce ourselves really quickly, again, my name is Alyssa Miller, and as Charlene mentioned, I'm an application security advocate for Snyk. I've been working in cybersecurity roles for the last 15 years, began as a penetration tester, been a hacker all of my life, but have slowly gravitated more towards the application security side, having been a former developer and so forth. So Garrett, I'll turn it over to you to introduce yourself.
Hey, thanks a lot, Alyssa. Hey, folks, my name is Garrett Gross. I'm actually the advisor for the VRM practice here at Rapid7, focusing on application security. My background is actually in network engineering. I was kind of conned into doing security and therefore made my way into application security. So it's kind of cool to have this dichotomy of Alyssa, who comes from the development and also, of course, the penetration testing background, and then someone like myself who came from just a security engineering background. So again, happy to be here.
Awesome. So again, happy to have all of you on board. And as we dive into this topic, I think anybody who works within an organization that does software development is at least somewhat familiar with the concept of DevOps development and what that has meant in terms of software development across the board. But what we want to do first is ask a question of each of you. So we have a poll question for you, and the question to you is, who owns the security of your applications, or who is the primary owner of security for your applications? Is it the developers? Is it the security team? Is it your operations team, or is it somebody else, or is it nobody? Who do you believe should own that?
And how interesting is this, Alyssa? Because folks, normally Alyssa and I have actually presented on this before in person. We usually ask for a show of hands. So the electronic polling, seeing that come in is pretty cool. But I don't know, Alyssa, what do you think? That's pretty in line with what we see in person.
Yeah, so we'll give them a minute to bring in the results. Looks like we're getting some pretty good participation. It is always fascinating to see how people answer this question.
Right.
Because 15, 20 years ago, I could ask this question and I think the responses would be very different.
Yep.
I think these days things have changed quite a bit in our attitudes towards who's really owning security. So Charlene, why don't we go ahead and we can give those poll results.
There we go.
And what you'll see is most people look to the developers. And this is consistent with what we're used to seeing. it's always interesting, and I think it's a reflection on what we're doing within DevOps in general.
Because I'd say 10 years ago, folks would say the security team would own security of everything. I mean, physical security, network security, application security. But as most of us, we're all kind of becoming software companies. Developers are becoming, the forefront. And I'd say that this is consistent with what we see both just in the industry and also just kind of what I've seen personally.
Yeah, and so what's really interesting then about this, if we switch back to our presentation, is Snyk asked this question kind of the market last year in our annual State of Open Source Security report. And part of that report, we do a survey of people who are working in the industry. And what we saw was very consistent with what we saw here today. And we see 81% of people point to developers as being responsible for security within applications. And, like Garrett mentioned, traditionally that's always been something we looked at falling to the security team. But I think that's very indicative of what we've seen change as we move more to a DevOps model. There's also just been kind of an understanding that developers really need to be aware of security principles and how they're coding. And if we think back to what we've done in years past, where we as an industry have talked about developer education and secure coding guidance, and so much of the efforts we've put from a security perspective into our development teams have been about educating them on how to be more aware and more capable of addressing security within applications.
Yeah, because I just argue overall, and you could probably draw a parallel to other areas of security, awareness training, just awareness advocacy does a whole lot in raising the security of an organization and kind of getting that culpability into all areas of the business, kind of what we're advocating here. I think that's key to an organization's success.
So as we start to look at DevOps, now DevOps and indeed DevSecOps has introduced some unique challenges from a development perspective. And I want to take a look at really quickly what some of those challenges are. When we used to think about software development, so if I go back 20 years when I started as a software developer, or even longer ago than that, but we won't talk about that. Back when I started, you thought about your application as this very monolithic, holistic element, right? You would look at your application, and if there were 700,000 lines of code, that meant that we had developers that wrote 700,000 lines of code. Now, we might have had different dependencies on system libraries and things like that, but the application itself, we looked at it, and our source code was all this stuff that we had written.
Well, you had visibility into everything. You were aware, you could see the interdependencies between the different pieces of code because it was spelled out in front of you.
Yep. So what's changed now is that when we talk about our applications, we have our code. We know our developers are still writing code every day, but the overall size of our applications is very different. So instead of those 700,000 lines of code all being code written by our developers write a small subset of code that then is drawing in libraries and packages from their development ecosystems. And now all of that becomes a part of our application. And as Garrett started to mention, we can look at our code and we can understand what those dependencies are. That's fairly easy to do. The problem comes in is that for every package that we now include in our application, that package has its own external dependencies that introduce other packages that now are ultimately a part of the code base that makes up our overall application. So where my developers maybe wrote 80,000 lines of code, those 80,000 lines now became 700,000 lines because of these dependencies. So by way of example, if I look at an application, for instance, here we've got just a very simple Java application. The application itself that the developers coded was 80 lines of code. And you see those represented here. 3 Java files, 80 lines of code, and they're done. But in one of those files, they declare all these dependencies. And you see a number of dependencies on the Spring Boot framework. And each one of those now brings in its own dependencies. We see the H2 database dependency at the bottom here. That brings in its dependencies. So now I've got 7 direct dependencies. But as I mentioned, each of those has its own dependencies as well. And so those 7 direct dependencies explodes into an additional 59 transitive or indirect dependencies that I may not even have visibility into. My 80 lines of Java code just became 713,000 lines of code. So this is where, from a software perspective, we start to see this issue of software supply chain security.
When I was going to say, you kind of hit the nail on the head. Even if you could get access to this code to make some sort of, assessment of the makeup of it, can you imagine making the business case for doing that analysis? I mean, that's just not even factored into the way that we develop software today. That wouldn't even be permitted, I don't think, let alone possible. So, I mean, where are we at, Alyssa? We're kind of at a pointing the fingers of it's not my job, it's their job. I can't see this. Where are we at?
Yeah, so I mean, you mentioned something kind of interesting, right? Enterprises at one time kind of thought with open source software, well, we're just gonna make policies that say we don't use open source software. And indeed, I still have these conversations today when I attend conferences or I have conversations with business leaders and development executives and so forth. And you talk to them about their open source, and a lot of times they're under the impression that they don't use any open source. The fact of the matter is, if you're doing DevOps development is enabled by the use of open source. And
That's right.
when you explore these ecosystems that are so popular in DevOps today, you find that this is just an inherent piece of it. And so to think that we're going to somehow eliminate this from our development processes is unfortunately not very realistic. And
No.
so instead, we have to start looking at how can we manage this. So a great case study that kind of shows the problem here. And I know this one gets beat up on a lot, right? I think anyone who lives or breathes in the security industry at all has heard plenty ad nauseum about the Equifax breach. But the fact of the matter is, this breach still stands as a really good lesson learned for what open source security really means to us in terms of our applications. So obviously we understand there were a large number, 150 million plus people who had data of their own exposed. You've probably read, you probably understand that there was a vulnerability in Apache structs that was responsible, or was the initial opening that the attackers leveraged in order to exploit this particular website. Now, what's a little terrifying here is that that vulnerability was disclosed in a CVE. You see the CVE here. Within a few hours of that CVE being disclosed, which means the vendor was already aware of it. All right, struts, there was already a fix available because that CVA does that responsible reporting. But within a few hours, there were still vulnerabilities the vulnerability was being seen exploited rather in the wild within hours. It wasn't until 2 months later that we found out about the Equifax breach. Now, how does this happen? Well, the issue is Equifax within their code didn't directly introduce that Apache Struts library. Instead, it was one of their application dependencies, a third-party dependency that they drew into their application that in turn was leveraging a vulnerable library from Apache Struts. And so you had this situation where Equifax was completely unaware that this particular CVE was something that was present in their code. And this is the problem of software supply chain security. When we don't know what that full dependency tree looks like and what we have within our code, as vulnerabilities are announced, it is extremely difficult to go out and then determine whether or not our code base is vulnerable.
Well, and you're exactly right. And we'll never know how this actually happened or why. I think there was a lot of finger pointing, at the corporate level with this. But if Equifax, a seemingly gigantic organization with very, very large security budgets, again, I'm not going to postulate what happened here, but if for some reason it was not possible for them to identify this exploitable vulnerability in their code, or specifically the dependencies code, how are folks that are in mid-size or smaller organizations with not the security team and not the resources of someone of Equifax's size, how are they supposed to mitigate this? I mean, they're not going to have the time, they're not going to have the resources. So again, what's the answer? You need some sort of force multiplier to do the heavy lifting for you, essentially.
Yeah. And so this is where within DevOps, we have been, from a security perspective, we've been preaching move left, shift left for years, and getting our developers more enabled to help us in this regard from a security perspective is where we need to keep moving.
Right. So we'll just throw out another poll real quick. Those folks that are listening, has your organization adopted DevSecOps culture? And that's a yes. We fully embraced it. We're firing on all cylinders. No, just patently we're not doing it. We're trying, which I'd say most folks are probably going to find themselves in this category, or I have no idea, meaning you don't know if you're adopting that, or maybe you're just not familiar with this push to SecDevOps. So we'll give folks a couple more minutes to answer that question. Alyssa, what has been your experience with organizations that move from your traditional development culture to this kind of coalescence between the orgs?
Yeah, so there's a couple things that I see. First of all, I think by far what I have seen in most organizations is we're trying is a very common answer.
Yeah.
There's a lot of ambiguity when you talk to organizations about, well, how do they even define DevOps or DevSecOps? And while there are many definitions out there, we find everybody kind of has their own. Additionally, there's not a good guide or best practices on how do you do this.
Yeah.
A lot of times people think about DevOps and DevSecOps and they think about automation and tooling, and that's about as far as they get into the conversation.
Yep.
And so as a result, there's not a lot of confidence out there from most organizations that they feel like, yeah, we are fully invested and we're fully engaged and this is what we're doing. That same survey I talked about before, within that same report, we also identified that only about 10% of organizations were at what we would call a level 5 or the top maturity level for DevOps. And
Right.
that's pretty telling of where people are at in that adoption cycle. So not uncommon And if we go ahead and close the poll and put it out there, you're going to see that that same pattern holds true for our attendees today.
Yep. Well, and what a lot, and you're exactly right. What a lot of folks don't discuss or don't really bring to the forefront is that this move to DevOps or to DevSecOps is not easy. It's fraught with a lot of probably a lot of financial heartache, a lot of just organizational heartache, probably a lot of lessons learned, mistakes made, so on and so forth. So yeah, this is definitely not surprising to find most folks in that we're trying stage.
So the less than happy news is it gets more complex, right? The challenges we always seem to have is that technology has not stopped moving. And indeed, within DevOps, we've made developers more responsible for the full pipeline, as it were. And so you see this comment from Kelsey Hightower. I debated how to reference this, and I figured I would just leave it in his words because it's perfect. You know, anybody who wants to spin up their own application platform, this is what we're looking at. Just this laundry list of technologies and things that, oh, by the way, we expect our developers to be able to help us define. So we've got developers out there defining Docker files and building Helm scripts and setting up Kubernetes configurations and so on and so on and so on. We expect developers, as we saw early on, to be helping us with the security of that. We're enabling them to push their influence further right into the pipeline. But if we're going to enable them to do that, we need to enable them from a security perspective as well. And that's what oftentimes is getting missed as we see organizations moving to more of a DevSecOps culture.
Yeah, and with each technology listed, I mean, just imagine there's subject matter expertise required for each and intricacies that are going to be found in each and how they interoperate. And, you know, arguably that's where we find ourselves in the biggest pickle is when we don't understand how these systems interoperate within one another. And then, you know, someone sharper or more determined than us identifies a way to exploit that tricky interoperability.
You know, one of my favorite parts about this quote, though, is that piece at the end, you know, where he says, you're going to need servers. So we focused on technology quite a bit, but then the next statement, you're going to need people. And when we talk DevOps and we talk DevSecOps, something else we tend to forget is that it's a culture change. And this is what really makes it difficult for organizations to absorb and to fully adopt. Because you're not talking about simply changing some processes and implementing new technologies. This is about a very inherent change to the way your people work every day. So when we look at DevSecOps, we kind of have this weird triple fold change in what we're doing with our people. First of all, as we have been for years, security is constantly trying to push left. We want to get earlier, we want to get involved in the development pipeline as early as possible because we understand from years of studies and years of our own work that the earlier we can identify the vulnerabilities in our application code, A, the cheaper it is to fix, and B, the easier it is to fix, and C, the more secure we're going to be overall. But with DevOps, we've now got developers pushing their influence further right, as I mentioned before. Not only are they responsible for writing code, we now expect our developers to be responsible for creating the infrastructure that their code is going to run on. They actually have the opportunity to define what operating system components are going to be a part of those Docker images that ultimately are going to launch their application. They're, in many cases, able to define what that Kubernetes cluster is going to look like from a configuration perspective before they take and deploy to production. And then finally, you've got the ops side of the house. So everybody that's in ops, because of all of this code-defined infrastructure and so forth that we're moving to, whether you're thinking in terms of containers or serverless environments, whatnot, everything's becoming more code-based. And certainly as we move into more cloud-native technologies in particular, our ops people are pushing up the stack. They're no longer, the ones that we're looking to rack and stack servers. They're out there having to define configurations at a higher level in the stack than they've ever had to do before. So the expectations here are that we're slowly creating this environment of shared responsibility. And it's that shared responsibility that is the absolute key to an effective DevSecOps culture, where security understands that they're not just responsible for security, they're responsible for enabling fast software development. They're responsible for ensuring the definition of stable infrastructure, whether it's containers or serverless or whatnot. Our developers understand that they are responsible for ops and security principles as well. And then finally, our ops people understand that, yes, they are there to also enable fast development, and they are there to ensure that that infrastructure is secure, just as the developers and the security folks are.
And you know what? You're exactly right. And Alyssa, I would argue that you need to remember that developers pushing right, security pushing left, these are, antithetical to what they're traditionally going to be doing. So it requires, just like you said, a lot of communication, a lot of trust, a lot of alignment within this shared security. So as Kelsey said in that tweet that you had up earlier, that glue that he's referring to, that's exactly what that is. That is the ability to communicate that we're all kind of pushing towards the same thing, even though our individual roles may be defining, separate, distinct paths from one another.
So let's take a look at this a little more in depth. And what is it that we need to change in terms of implementing this culture effectively within our organizations? If we look back at what we've traditionally done, how we've traditionally approached security in particular within what we traditionally called the SDLC, we thought of security, and it was typically presented to developers as gates. Each phase from one step of SDLC to the next had this security gate in between that they had to pass. So we had a product backlog. We had all these features that we knew we wanted to implement. And before we would start coding on them, from a security perspective, we told developers, well, you got to go through a threat model. We need to understand this. We need to look at what can possibly go wrong. And then let's define security controls that you need to implement as part of your code. Great, good idea. So then we open them up to code. Now the code happens, we get to a certain point, and we decide there's another security gate. Well, before I'm going to let you push that into a regression test, you need to go through this static code analysis, and maybe some of us are even good enough that we were doing software content analysis as well. So that was another gate, another hurdle. You had to achieve a certain score on your secure code scan before you could move into test. Then you went into test, and we tested all the functionality, but then before you could move to a point of deployment, well, we wanted to do dynamic security testing. So we would do that, and there was a feedback cycle from that, and we had to go back, and changes had to be introduced, and we had to come through the whole process again. And then finally we go and we deploy, but as part of the deployment, now we have to do a penetration test. And before we certify this and hand it to ops as ready to go, we do that penetration test, and we have to identify any additional vulnerabilities that may exist. And so this was always the approach. The problem is, when we go to a DevOps model, we can't afford these gates, because these gates introduce a long feedback cycle that really breaks that whole model of shared responsibility and dynamic, fast-paced development that we always associate with a DevSecOps culture. And so when we think about the pipeline and we think about these gates, we start to realize these gates need to disappear. But these are legitimate and important security principles and practices that we're talking about here. So what we need to do instead, we need to keep those, but we now need to introduce them as part of each of these phases, not the gate that comes at the end. So for instance, let me start right at the beginning. When we think about threat modeling, and we always thought about threat modeling, well, I plan out my sprint maybe, and I threat model this thing, or we've oftentimes threat modeling is done as I'm going to look at the application holistically, and I'm going to draw data flow diagrams, and we're going to do all this analysis, and we're going to use these big frameworks that talk about technical security threats like Stride, and I might use Dread in order to understand the risk of these particular threats and how I want to design controls. And then we got even bigger. We built CAPEC, which was going to be, I want all these common vulnerabilities and threats that I have to be worried about categorized somewhere. Well, that's a big, heavy lifting process that doesn't fit anymore within DevOps. So how do I bring threat modeling into the backlog? This is where we can start to think about user stories that actually contain threat modeling information. So if my goal in threat modeling is to say, this is the worst, these are the things that could happen that would be bad, I want to leverage that business context. So my business-minded folks that are writing those user stories, they're the ones that I want to start to introduce the threat modeling side of this, whether it's abuse stories, whether it's analysis of critical assets that are a part of that user story and how they're likely to be impacted, capturing that information into the backlog in each individual user story enables this idea of continuous improvement, where I'm not trying to threat model my entire application all at once. Instead, I can threat model just that small component as I put it in the backlog. So as we move through the rest of this chain, we think about coding, and where we're developing and we're committing code to a repository, having tooling that allows our developers to view security information real time within their IDE, having those integrations into the code repositories where we can start to understand that software supply chain, the software bill of materials, or SBOM, if you will, that is a part of that application, understand that in that coding cycle before we even introduce this to test, because now that helps drive my test cases. And it just continues on down this path of now, rather than having these gates, we are using technology and process to enable the people who are a part of each of these phases to conduct those activities or to make those security practices a part of each of those phases that they're responsible for.
Oh, and it's a more efficient, just holistic process. You start looking down the line at running SAST and DAST scans and container assessment, stuff like that. These were traditionally things, like you said, that would not only gate the progress and hold up the development lifecycle, but it caused a lot of stress and a lot of tense interactions between the teams, to where, and again, I'm not naming any names, but you'd have teams that would just poke holes in the tools to prove that they weren't effective enough because they didn't want this extra 2 weeks of work, this extra brunt of reviewing your DAST results before you could move on to the next project. So yeah, I'd agree that this motion, this kind of integration within each phase is not only better for the security ecosystem, but just essential for the way that we want to do business today.
And that's an important point. And this is what's really ultimately at the heart of making your DevSecOps pipeline efficient and effective. It's this idea of frictionless enablement. How do I enable my developers, my ops teams, my security team to do this with tooling that doesn't introduce additional friction to the pipeline. So understanding that if I'm going to launch a new security requirement, how does that impact my developers? Because the more friction we create, as Garrett just mentioned, it just hampers our ability to adopt those new strategies, those new initiatives into our pipeline. So how do we reduce that noise and fatigue? Well, I mentioned already the idea of threat modeling. We don't want to lose this because threat modeling, indeed, that drives into the subsequent phases of our pipeline. It helps me to risk prioritize where within my application I want my developers to spend the most time. When developers have that information at the front end, as they move into their actual coding cycle, now they're able to accommodate that. And they're able to have that mental planning of those fixes early on before they've even started to write the code. So now as they're developing the code and they encounter one of those points where there's a particular threat, whether it's they need to introduce authentication or they need to introduce some form of data protection, whatever that security control is already something that they've accounted for as part of their development life cycle. So when we're talking DevSecOps here again, and DevSecOps so often is that idea of the continuous integration, continuous deployment model, CI/CD, for those of you that are familiar with the term, getting that knowledge in their minds early and enabling them to think about it as they're coding, and then giving them the tooling that supports that is crucial. And then to continue reducing that friction, all of that information that's now flowed from our threat model through our developers now educates our test cases. So we're able to even streamline the testing and really tailor our testing to the threats that mean the most to us from an organization. Instead of having to test for the world of vulnerabilities, which we still want that comprehensive picture, but don't we really want to prioritize those vulnerabilities that mean the most in terms of threat? What are the vulnerabilities that are the highest priority? What are the vulnerabilities that could most easily pivot into additional vulnerabilities and exploits, or directly expose data in some way, or directly expose our systems to denial of service or other such attacks?
Yep. And I really like what you said about the whole, integrating with the process rather than being perceived as an interruption, because I think that's key here. And also I like how you said about, you get developers thinking about security, because just to the point of shared responsibility, as we in security are trying to better understand these development processes and better augment and better impact them, but by integrating with these systems and providing something that's not perceived as a nuisance or something that's adding extra work, I've seen in my experience, developers, this is kind of a catalyst to get them excited about security and get them to take a little bit more seriously, to where as they're writing the code, just like you said, Alyssa, they're thinking about these security concepts. They're seeing these patterns and these explicitly like injectables or reflectables or stuff like that, seeing that manifest within their code as they're writing it. It's pretty cool.
Most definitely. And I dropped a little hint there earlier, and I hope you caught it. When I was talking threat modeling, I talked about bringing in that business context. So we talked, we had DevOps came up in 2008. A few years later, we started talking about DevSecOps because we wanted to keep security in the conversation. Well, I mentioned the business people. I shudder to say biz DevSecOps because I don't think adding more terminology to it is what we need. But what we do need to do is focus on that overall sense, that overall culture of shared responsibility, where everybody from the very beginning of the process, those business people who are taking potentially requirements from users or are developing user stories on their own based on whether it's bug fixes or whatever, we need that understanding, because if we don't understand from a business perspective what the critical assets are, we don't know that we're trying to defend the right things. So bringing business, bringing developers, bringing operations, and bringing security all together needs to be our focus. And then we get to the part that everybody talks about when we think about DevOps and DevSecOps. We think about this idea of automation. This is still crucial. So while I've kind of downplayed it as the thing that we all know about and everybody focuses on it and forgets everything else, it's still, there are a lot of questions around how do we leverage automation. And specifically when we're talking open source, where we started this conversation, think about the situation where I've identified a subdependency in one of my packages that's a vulnerable dependency. So I'm including version 1.5 of package Y, but it also then is dependent on version 2.4 of package Z, and version 2.4 of package Z happens to be vulnerable to some form of attack. How do I go about fixing that? Well, for me, within my code, it's an open source package, right? So I could very easily fork that package from the repository. Let's say it's in GitHub, and I can fork that. I can make it part of my own. But now I've separated myself from that open source community. I'm no longer necessarily connected to that package. Now I can go in, I can edit those dependencies myself as part of that, but isn't what I really want to do, don't I really want to fix that and send that as a pull request back to the package maintainer? Because now not only do I fix it within my code, but now I can fix it for the entire community. And so in automating that ability to submit those pull requests, to make that change and submit that pull request, if I can automate that, I've got tooling that tells me that, hey, here's this vulnerability. So isn't it so much easier if that tooling can say, hey, here's your non-vulnerable version, upgrade to this, and it can actually make that change and submit that pull request back to the maintainer. I also mentioned build integration before. Being integrated into those areas where my builds are happening. So whether it's the repository where the code is coming from, whether it's the tooling that I use to orchestrate those builds, things like Jenkins and so forth, having tooling that's integrated into that and able to watch for vulnerabilities and able to discover them and alert on them is crucial, because now the developers can continue with their typical cycles of commit and move on. And that all happens, all that security tooling does its job in an automated fashion. And it's not something that they have to be worried about. It speeds up that feedback cycle. So we're no longer waiting on outside organizations, because everybody's responsible and everybody's worked together to put that automation in place.
Well, and you're also not asking them to use a separate tool. If you're using the example of like DAST integration or SAST integration with their IDE, they're staying within, you know, that same tool that they're using, and they're not being asked to go visit another dashboard with some nomenclature that they're not familiar with and stuff like that. So again, it encourages them to take this seriously. And, you know, again, if you kind of get this firing on all cylinders, then you end up accelerating the release cycle, because it's just part of the process now. Just like you said earlier, Alyssa, it's expected, it's part of it, and it's just built into how much time they factored into the release cycle.
And so then obviously we've talked all the way along about the idea that our infrastructure is becoming more code defined, right? I'm staying away from infrastructure as code, because that's kind of its own animal and has its own connotation. But indeed, whether we're talking containers, we're talking cloud native technologies, we're talking serverless environments in particular, all of that is ultimately software defined somehow. And so the idea of verifying those configurations is also crucial, and doing that in an automated fashion. So how can we make that easier, that as our developers deploy or write their Docker files and they write these Helm scripts and so forth, how can we make sure that we've addressed security sufficiently? How can we make sure those Kubernetes configs are safe before we deploy them to production? And then finally, we've got all this information, using that in an intelligent fashion to really enhance our monitoring, so that all that production monitoring that we're doing, all that tooling we put in place, now has the intelligence of everything from the pipeline built in, that it's able to leverage and quickly identify where vulnerabilities exist, and to go back and to execute on these automations when necessary. So finally, where we're trying to draw in our developers and build this shared responsibility culture, we need to meet our developers and our operations people, and I'm speaking from a security perspective now. We need to meet them where they live. You see on the screen here many of the technologies and the ecosystems that are very well understood, popular, very common in today's world of software development. And it starts from the beginning with things like Jira for backlog management, and Slack handling our notifications, the IDEs, whether it's VS Code or IntelliJ or Eclipse, you see them here. We see our code repositories, those continuous integration tools like CircleCI and Jenkins and so forth, our containerless environment, our container and serverless environments, excuse me, and even when we get to platform as a service offerings, having the technologies integrated throughout that pipeline and being able to give those developers tools that are easy for them to use, that because they're integrated into all these technologies that developers are using today, they don't introduce new friction, and instead they make it easier for developers to do their job overall, not just thinking about security, but thinking about the entire breadth of what we're asking developers to do today. So as we start to wrap things up, I point out to you, you've heard Garrett and I share a lot of information about enabling DevSecOps. Certainly the tools that we come here today representing are tools that are meant to create this environment for you. So when I talk about Snyk and I think about what Snyk means to the developer community, that focus on enabling the developer throughout these integration points, our partnership with Rapid7 and how Rapid7 ties in and provides that additional tooling and visibility across this entire pipeline with Snyk, where they come together and we drive that greater developer, the greater operational, and the greater security enablement. This is what DevSecOps is truly all about. It's building that culture, enabling that culture through process and technology, and ensuring that our people are supported throughout.
Yeah, agreed wholeheartedly. And I would just echo that and say that on top of all this tooling and all these processes, keep communicating and just keep trying to understand one another and communicate each shared goals. And I think that's where the future of secure environments really lives.
So with that, I think we're probably going to open it up to questions at this point. If you have a question that you haven't asked so far, please go ahead and throw that into the questions tab, and I will turn this over to our host. If you want to start addressing those questions, we can go through those.
Absolutely, sure. There's plenty of time, guys. If you have a question, go ahead and use the GoToWebinar control panel and submit it. We have about 5 minutes or so we'll go ahead and take as many as we can. Here's a question for you. Excellent webinar, as usual. Thank you very much. My question is, would you please suggest some recommendations on how to implement SAST, IAST, DAST, and RASP with solutions like Secure Code Warrior, etc., if you want to include test in your DevSecOps pipelines.
So the good news is there's a number of solutions in the marketplace that offer those integrations. And when I say integrations, that's where I'm talking about. Again, I'm actually going to back up the slide here. What I always recommend is, first and foremost, it's got to be driven by your environment, right? We don't want security tooling to dictate what technologies we're using. So instead, looking for those technologies that tie into pieces early on, right? So from a code repository perspective, what can I do at the code repository to really look at my software content analysis and really start to build out that SBOM, understanding what my developers have done in terms of introducing dependencies that maybe we're not aware of, and building that SBOM. When I get to continuous integration, and now I've got that promotion process and that build process, that's where I really want to see SAST come into play. So I'm looking for, if I'm leveraging Jenkins, most of the major SAST offerings out there support Jenkins. So that's what I'm looking for in that case, someone who can offer me that automation where I kick off a build and the SAST tool is just a part of that build process and it happens automatically. And I get that immediate feedback from the tooling as a result of that automation. So now my developers aren't waiting 3, 4, 5 days for a manual code review to come back with a list of vulnerabilities. They've got immediate and actionable responses that they can now fix quickly, where things don't even have to become a part of the backlog for those fixes. And then as you move into production, of course, now when we're talking about runtime assessment and so forth, being able to find that tooling that's available that ties in, whether it's your cloud environment, with all of us moving to cloud today, there's a number of different solutions that are available within, say, the AWS Marketplace or within Azure. Really finding the one that's going to tie into your environment and make that automation happen for you. There's no reason, unless you're using something a little more specialized, that you would necessarily have to do this manually. Most of them now have those integration points built, and that's what's really crucial to be looking for.
Yeah, and so when you're talking about integrating DAST and stuff, your natural knee-jerk reaction is, I just want a DAST scan at the time of deploy, which is fine, and that's normally what we end up seeing. So integrating with a build automation tool and just putting that as a step in your build or deploy process. The next step to that, though, is actually gating the scan. So you could do things like go ahead and let the build proceed, but if I find any vulnerabilities that match the following criteria, go ahead and kill this build process. Again, that's a little bit more of a advanced take on it. It requires some maturity and definitely some familiarity with adopting the DevSecOps process, but that can be a very, very powerful control in getting that earlier on. And again, as we discussed, fixing that earlier on is not only financially better for you, but also just customer confidence, availability, stuff like that. When you talk about runtime availability, the problem there, or not the problem there, the challenge there is getting something that's going to fit in with whatever software is running. So typically runtime visibility is going to be language dependent. So you need something that's going to run within that code to give you visibility at, the class loader or stack trace to try to understand what's actually being leveraged at runtime. And if that's not available, typically you could leverage something like just HTTP traffic inspection, sort of like a WAF type functionality to understand what's going on. And again, you could have a phased approach with that as well. You could just do something to where you're getting awareness of the activity, and then maybe phase 2 would be that you're going to start blocking activity that deviates from some sort of whitelist that you've set up.
All right, great. So I think we have time for one more quick question. Does Snyk do composition analysis and compliance workflows?
Yeah, so from a Snyk perspective, we are able to do the composition analysis. So Snyk will walk those directory trees or those dependency trees for you. Boy, I'm having a tough time spitting it out here at the moment. So what Snyk will do is Snyk will analyze your complete dependency tree and identify the vulnerabilities in all of your dependencies all the way down. So rather than just looking at what code you're dependent on, it will walk that full tree, understand all the indirect dependencies as well, and alert you to any vulnerabilities that exist within any of those sub-dependencies. From there, it does actually provide the ability, like I mentioned before, of automating fixed PRs. That's one of the things that Snyk does really well, is not only alerting the developer and saying, here, this is the vulnerability, here's the least updated version that's non-vulnerable, but additionally, we'll automate that whole process of introducing that change to your code and then sending that fixed PR, that fixed pull request back to the package maintainer. From a compliance side, we can integrate into a number of different compliance workflows. Really, in that case, if it's something custom, we do have a command line interface when all else fails. In terms of, we have countless integrations. You see many of them on the screen right now. But we are also able to do that custom integration either through our API or through our command line interface.
Excuse me. All right. Okay, so we're about 4 minutes to the top of the hour. So unfortunately, that's all the time that we have for the question and answer period. If we didn't get to your question, I apologize. But please know that the folks at Snyk and Rapid7 will be getting a copy of all of the questions. So I am sure that they'll be more than happy to follow up with you offline. Okay, at the top of the hour, I did note that we would be doing a drawing for 2 $50 Amazon gift cards. So at this point, let's go ahead and get that done. Let's see, our first winner for today is Gerald W. Congratulations, Gerald. And our second winner today is John K. Congratulations, John and Gerald. We'll be following up with you via email following today's webinar to get your gift card out to you. Also want to remind the audience that today's event has been recorded, so if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. That should be hitting your inbox probably within an hour or so. The webinar is also going to be living on the Security Boulevard website, so you can always go look for it there. Just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. Alyssa and Garrett, thank you so much for such a great presentation. Got lots and lots of feedback from the audience, and they loved it. So thank you so much.
All right, thank you so much. Everybody have a wonderful day.
Thanks, folks. Take care.
Right, and I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.